The first step in training a transformer model is tokenization, breaking down text into smaller components called tokens. While it may seem intuitive to treat each word as a token, tokens can also be parts of words, whole words, or a combination of words and punctuations. Tokenizations allow models to process text efficiently, ensuring that even unfamiliar words can be understood in a context. So, how tokenization works? Imagine we have a sentence: I heard a dog bark. A simple tokenization process might assign IDs to each word, like I, which is token 1, heard, token 2, a, token 3, dog, token 4, and bark, token 5. The sentence could be represented numerically as 1, 2, 3, 4, or 5. Now, let's say we introduce a new sentence: I heard a cat. Since the word a already exists as token 3, it will be reused. The new sentence is represented as 1, 2, 3, 8, where cat is assigned as token 8. So, as training continues, the model compiles a vocabulary. A collection of all unique tokens has been assigned. With a sufficiently large training dataset, this vocabulary can grow to introduce thousands or even millions of tokens, allowing the model to recognize and process a wide range of words and phrases. So, why tokenization matters? Tokenization is a crucial step in training language models because it standardizes text inputs, making it easier for the model to process. It enables efficient learning by recognizing repeated words and assigning them constant tokens ID. It helps the models generalize, allowing it to understand the different combination of words without retaining each one of the phrases. Tokenization is the foundation of language modeling. By breaking it down into text, the structured unit, it enables models to learn, predict, and generate natural language efficiently. In the next lesson, we're going to be talking how these tokenized representations are used in embedding to capture the meaning of word.